Alright, here we are at the last section of Chapter 6, which is also the last new section that you're going to learn for the rest of the semester. Yay, everybody throw a party! Okay, so this will also be a pretty simple chapter, because what have we done at the end of every chapter where we've learned about new functions? We've graphed them and talked about translations. So what do you think we're going to do? We're going to graph them and talk about translations. Okay, so graphing radical functions. Our objectives, we're going to answer the question, how do the graphs of radical functions, not how do, what do? There we go. I'm pretty sure I can read, maybe. So what do they look like? So we're going to graph square root functions and other radical functions like cubes and cube roots and stuff. Alright, for your vocabulary, we have two words. Inverses of the power function y equal x to the n power with domains restricted as needed form parent functions that are inverses of y equals the nth root of x for families of radical functions. So remember, inverses, opposites, all those kinds of things. So x to the n power has an inverse, the nth root of x. In particular, f of x equals square root of x is the parent function for the family of square root functions whose general form is y equals a square root of x minus h plus k. Now, do a, h, and k look somewhat familiar? You know, they should be pretty familiar to you, by now. So a is the value that stretches or compresses your function. H moves left and right, k moves up and down. Just like always, nothing's changed. Alright, so translating a square root function vertically. What are the graphs of y equals the square root of x minus 2, x squared of x minus 2, and y equals the square root of x plus 1, and we're going to compare that to our parent function, y equals the square root of x. Now, what we're going to do is we're going to, no, I gave it away. Okay, so we're going to pick some points. So if we were to graph y equals the square root of x, if we want to choose, we're just going to make an xy table to get an idea of what this looks like. Can we have any negative values to put in for x? I mean, we could, but we get imaginary numbers, and we can't really graph imaginary numbers. So our smallest number we can pick is 0. A square root of 0 is 0. Let's talk about perfect squares. Is there a square root of 1? It's 1. Is there a square root of 2? No. Square root of 3? No. Square root of 4 is 2. Square root of 9 is 3. Notice the pattern? Okay, so we have 0, 0. That's here. Okay, and then I have 1, 1 as a point. I have 4, 2 as a point. 3, 4, 2 as a point. And then I have 9, 3 as a point. So, square root functions do this kind of thing. They stop at 0, 0. Now, if we wanted to graph y equals the square root of x minus 2, I'm feeling kind of Christmassy. So, square root of x minus 2. So, we can pick the same values. 0. So, square root of 0 is 0, minus 2 is negative 2. Square root of 1 is 1. 1 minus 2 is negative 1. Square root of 4 is 2, and 2 minus 2 is 0. And the square root of 9 is 3. It's 3, and 3 minus 2 is 1. So we have 0, negative 2, 1, negative 1. There. 4, 0, and 9, 1. What happened to our function? Well, it looks to me like it went down 2 units. To keep it with the Christmas spirit, I'm going to use gold, because that sounds fun. Square root of x plus 1. Okay, if x is 0, y is 1. If x is 1, y is 2. If x is 4, y is 3. And if x is 9, then y is 4. So we have 0, 1, 1, 2, 4, 3, and 9, 4. What happened this time? It went up 1 unit. So adding or subtracting a number onto the end, just like before when we did quadratics, moves it up and down. Crazy! Okay, so there you go. Oh, there's a picture. So we're not going to take the time to do these, but inside not the absolute values, the square root, what's it going to do? Move it left and right. What? No way. Okay, so if it's x plus 4, is it going to move it right or is it going to move it left? Well, just like we've always talked about before, it's the opposite. So if it's plus 4, it's going to move it left. If it's minus 1, it's going to move it right. There you go. Ta-da! It's so fabulous. All right, now we're going to have composite functions. Well, not composite functions, but, a little more to it. So y equals 1/2 square root of x minus 3 plus 1. Okay, in this, you have to kind of do it in steps. So what you're going to do first is you're going to choose points from your parent function. Well, parent function points, so my x values are 0, 1, 4, and 9. So we're going to choose those points. Those were x values. What were our y values? Choose points from the parent function. Okay. And we're going to multiply those y values by negative 1/2. So we're just going to do the negative 1/2 part first. So it's not what you think. We don't move it left, right, up, down, and then multiply by negative 1/2. We actually multiply by negative 1/2 first, and then move it left, right, up, down. Okay, so our x values for our parent function were 0, 1, 4, and 9, and we got 0, 1, 2, and 3. So now we're going to take and multiply each of these by negative 1/2. So we get 0, negative 1/2, negative 1, negative 3/2. So these are our new coordinates. So 0, 0 is still our starting point. 1, negative 1/2, 4, negative 1, 9, negative 3/2. Okay, once you have those, you plot those, and then from there you go minus 3 goes right 3, and plus 1 goes up 1. So take each of those points. So 0, 0, we go right 3, so that's 0, 3. We go up 1, so our point is actually 1, 3. So that's our new point. So from negative 1/2, we go right 3, so that's 4, no, 0, 3. I did that backwards. Okay, well anyway, I have a picture for you. I like pictures. Pictures are good. There we go. So you can see step 1 is our parent function. That's the black dotted line. And then negative 1/2 makes it smaller, compressed. Also reflects it across the x-axis because, it's negative now. And then, that's the blue one. Nope. No, that's the red one. Woo! I'm getting all sorts of messed up. Okay, it reflects it across the x-axis, so it makes it closer to the x-axis, and then reflects it across the x-axis, and then from there, we move it right 3 and up 1, and that's where you get the blue line. Okay, so the blue line is our final answer. Final answer? Final answer. Okay. You can model the population P of Corpus Christi, Texas between the years of 1970 and 2005 by the parent function P of x equals 75,000 times the cubed root of x minus 1950. Using this model, in what year was the population 250,000? Okay, either we can solve this algebraically and do a bunch of numbers and a bunch of crunching and a bunch of blah, 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 blah. Or we can use our handy-dandy graphing calculators and we plug in our two functions. So we're going to graph the two equations. So your one equation is, so in your y1, helps if I have the, okay. In your y1, you're going to put 75,000 cubed root of x minus 1950. And to find the cubed root, you go to math, and it's number 4. And then in your second function, your y2, you're going to put, you want to know when it's equal to 250,000. So go ahead and graph those two. You're probably going to have to change your window because these are some pretty big numbers. And then find where their intersection is. Where the two lines intersect each other, they kind of do a, this kind of thing. Where the two intersect each other, that's where your solution is going to be. So go ahead and put that into your graphing calculator, find where they cross. What year is it? I'm not going to tell you yet. You have to do it yourself. What year is it? It's 1987. I was 3 years old. Shh, don't tell. Okay. Graphing a cube root function. What's the graph of y equals 2 times the cube root of x plus 1 minus 4? Okay, so what we're going to do is we're going to first start by graphing our parent function, y equals the cube root of x. So, that means we're going to have to pick some points, because we don't know what a cube root looks like yet. Or do we? No, we don't. Okay, so we're going to pick some points. So, x, y. What are some numbers that we've used so far that are perfect cubes? Well, we have -8, we have 0, we have 8. So that's cube root of -8 is -2, 0 is 0, 8 is 2. So we have -8, -2, 0, 0, 2. Okay, so when I do it like this, it looks like it's just going to be a straight line. But go ahead and graph it on your calculator, and it's actually going to do like this kind of thing. That kind of thing. That doesn't feel right. Does that feel right? Hold on a second. I accidentally deleted my drawing. Okay, so, oopsies. So what it does is it kind of goes like this. There we go. That looks mostly-ish better. Kind of. I have issues with drawing things. It's really quite terrible. Okay. Anyway, so it looks kind of like that. So that's our parent function. So that's what we're going to be going off of. So then from there, remember we picked the points -8, 0, and 8. In order to graph it, we're going to take and multiply all our y coordinates. So -2, 0, and 2 by 2. So -2 times 2 is -4. 0 times 0 is 0. Or 0 times 2 is 0. And 2 times 2 is 4. So we have those as our new points. And then we're going to go ahead and translate those. So we're going to go left 1, down 4. So move all those points left 1, down 4. And here we have, see, that picture is so much better than mine. Anyway, so the black one is our parent function. The red one is that times 2. And then the blue one is with the translation. So left and down. And it looks kind of weird. They kind of look like snakes, but not snakes. And they're strange things, but, you know, anyway. And then rewriting a radical function. Let's rewrite this function so we can think about it as transformations. So y equals the square root of 9x plus 18. Well, we don't know how to do that because we haven't done anything with anything in front of the x itself. So is 9 a multiple of both 9 and 18? Yes. And is 9 a perfect square? Yes. So let's go ahead and rewrite it as 9 times x plus 2. What's the square root of 9? 3. So we have 3 times the square root of x plus 2. So our parent function is actually 3 square root of x. And then that's been shifted to the left 2 units. So all those good old translation things. They're so exciting. Okay, so here's your lesson check. I want you to graph y equals negative square root of x plus 3. So use your function rules and use your square root. And then I also want you to rewrite the cubed root of 8x plus 16 and then describe its translation. You don't have to actually graph this one, but I want you to rewrite it and then describe the translation of how it moves from the parent function. And your homework is to do 6-8 and to go ahead and start on that practice test. Remember, we have the test on Friday, and then from there we're just going to be reviewing. I'm going to give you plenty of time to ask questions and stuff before your final the following week. So have a great night and see you tomorrow.